Alright, class, we're going to do 9-5 today, symmetry. Our objectives: identify and describe symmetry in a geometric figures. Okay, line symmetry. A figure has line symmetry or reflection symmetry, same thing, if it can be reflected across a line so that the image coincides with the pre-image. So guys, just like the activity we did with the mirror, with the bug, where you put your mirror was the line of symmetry or your reflection line or your reflection symmetry. The line of symmetry, also called the axis of symmetry, divides the figure into two congruent halves. Okay, so you have this heart here, and the red dotted line here is your line of symmetry because this half is exactly like that half. A figure has symmetry if there is a transformation of the figure such that the image coincides with the pre-image. Okay, tell whether the figure has line symmetry. If so, copy the shape and draw all lines of symmetry. Alright, class, I had to kind of manipulate your all shape, so it's not going to look exactly like this one, so I didn't have to waste like 10 sheets of paper. So if your star, your diagram, polygon, look like this one, does it have line symmetry, and if so, how many? The answer is yes, and there are 8 lines of symmetry. Okay? So you've got 1, 2, 3, 4, and then you've got 5, 6, 7, 8. Tell whether this figure has line symmetry. And it does not. There's nowhere where you can draw a line where it has the line of symmetry or the reflection symmetry. Okay, what about shape A here? Yes, 2 lines. You can do it horizontally or vertically. What about B? Yes. You can do it horizontally. And then what about the flag here? Yes, 1 line of symmetry. Okay, a figure has rotational symmetry or radial symmetry if it can be rotated about a point by an angle greater than 0 and less than 360, so that the image coincides with the pre-image. Okay. The angle of rotational symmetry is the smallest angle through which a figure can be rotated to coincide with itself. The number of times the figure coincides with itself as it rotates through 360 degrees is called the order of rotational symmetry. Okay, so we've got this, looks like a square, and we rotate it, and we can rotate it 4 times. So 360 divided by 4 is 90, so the angle of rotation is 90 degrees, and the order is 4. Alright, what about A? Does A have rotational symmetry? It does not. And guys, this is where I would take my paper and rotate it to see if you can get it back to the same exact figure, the pre-image. And the only way you can get this back to the pre-image is if you rotate it 360 degrees. Well, every object has 360 degrees rotation symmetry. Okay, what about B here? Yes, you can rotate it 180 degrees. So you rotated it twice. So the order is 2. 360 divided by 2 is 180. What about C? Yes, you can rotate it 4 times to where it goes back to the original figure. 360 divided by 4 is 90, so the order is 4. Okay, try these 3 on your own. A is yes. You can rotate it 3 times. So the angle of rotation is 120 degrees. The order is 3. B is yes. You can rotate it twice to get to 180 degrees. And C is no rotational symmetry. Okay, describe the symmetry of each icon. Don't worry about copying the shape. You can just draw over what you have there. If there is a rotational symmetry, give the angle and order. So what do y'all think about this diagram? Is there line symmetry? Is there angle of rotation? Or rotational symmetry? There's no line symmetry, but there is rotational symmetry. You can rotate it 180 degrees, so the angle of rotation is 180 degrees. The order is 2. All right, what about this diagram? Is there line symmetry? There sure is. So there's 4 lines of symmetry, and there's angle of rotation is 90 degrees, and the order is 4. All right, a 3-dimensional figure has something called plane symmetry. Plane symmetry is just like the line symmetry with the 2-dimensional shape. If a plane can divide the figure into 2 congruent reflective halves, it has plane symmetry. So this is a 3-dimensional shape, and you all can see the plane symmetry right there in the orange down the middle. A 3-dimensional figure has symmetry about an axis if there is a line about which the figure can be rotated by an angle greater than 0 degrees and less than 360. Okay, so we have a cylinder here. Symmetry about an axis. Tell whether the figure has plane symmetry. If so, okay, tell whether the figure has plane symmetry about an axis or neither. Okay, it has plane symmetry because you can put this plane down the middle of this pyramid here. And it also has symmetry about an axis, this dotted line. If it was stationary, you could rotate it around and have plane symmetry. All right, what about this figure? All right, you do have plane symmetry right down in the middle. It'll cut it in half. We have 2 L's there. Does it have anything else? Sure doesn't. So let's go back and look at that. Okay, so symmetry about an axis. So if we had a line through here and you rotate it, would it look the same? No, you'd have to rotate it 360 degrees. Okay, what about a cone? Plane symmetry? Yep. Symmetry about an axis? Whoops. Yeah, it sure does. Because your plane symmetry about an axis would be about right there, and then it would rotate around it. All right, guys, that's it for 9-5.